Hello everyone, this is Sam from HiPy. Today we're going to be doing a very short 5-minute video. I promise to keep it short this time on Matplotlib. We're just going to work straight through the worked example. So before, at the very start in Basics 1, we were looking at the functional way to make graphs. So I'm going to go enter a little bit and you'll see why later. Actually no, I'm not. I'm going to go import matplotlib plotlib.pyplot as plt, and then we're going to see here import numpy as np, because we're going to be using numpy, and then we're just going to go x equals np dot linspace 0 to 10 with 101 points in between, and then we can just say plt dot plot x squared, and then we can just say plt.show and we will get the x squared graph out. That's fine, that's fantastic. The problem with this is we can run into some problems later on. What happens if we wanted to create like a graph here, for example, a graph within a graph? What happens if we wanted to create subplots? We can kind of do subplots, but it gets a bit messy very quickly. So the proper way, you should really be doing something if you're not just doing a quick graph that I think I do in all the guides. I just do a quick functional graph. If you want to do a properly nice looking graph for a paper or for a presentation or whatever, I implore you to do it the object-oriented way, which is the way that I'm just going to describe now. So the object-oriented way involves we set up a blank canvas and then we start adding elements to it. So we start with the blank canvas, which we're going to call fig, and we do this by running the plt.figure command. So this creates a figure, and then we run axes equals fig.add_axes. And then in this function we take a list of the coordinates that we want this to be at. So we're taking 0, 0, 1, 1 for now. Then what we can do is we can plot different functions on this set of axes. So we're going to go x and np.x for x, which means it's e to the x. And then I'm just going to take this line and copy it because we have a lot of... Oh, I've just executed it by accident. How many are we doing? 5, yeah. So then we're going to have 2 to the x as one of these, 2 to the x. We're going to have 3 to the x as one of these, 3 to the x. We're going to have x squared, and we are going to have x cubed as one of these. And then if we press, we're going to need to do plt show because it's not showing us the graph. And then we see all of our oh, that's not good. Okay, let me just try shift enter again. There we go. Okay, so it worked that time. It can be a little bit weird with just getting it to show one graph, so just make sure it works. Well, you might have to run it a couple of times. So we can see here now that we have a number of different kind of graphs. Some we can't really look at that much, and to be honest, I couldn't really tell you the difference between there's supposed to be 5 and we can only really see 4. This is just basically because our y limit goes up to 60,000. We just don't want that to be the case because we can't just see the difference between I think there's going to be 3 here or maybe 3 here or something. It's just not a good way of doing things. So our 2 jobs here now that we couldn't do with the functional method is just to make it really clear what these lines mean, and then to shrink this y scale down so we're only looking basically from here to here, or even from like here to here or something, from 1000 to 0. So setting up the axes so it doesn't kind of go that far is actually really easy. We just do the dot set y lim, and then we have to enter in a tuple, which is the y limits. So we see here, we get 0, 1000, and we can see now we have nice and 1000. We can see really clearly we have 1, 2, 3, 4, 5, just nice graphs that we're going to see. But you might still say to me, like, how do I know which is which? And that's when the legend comes in. So the legend, we have to run the axes.legend function, and then for Python to know which is which, we are going to have to explicitly tell Python what to label each of these plots. We have label equals exp, we have label equals 2 power, we have label equals 3 power, we have label equals squared. Ooh. I'm just going to write sq for squared, and label equals cube, which I'm just going to say cu. And then if we press shift enter here, we can see we have exp 2 power, 3 power, squared, cubed, and we can just easily, very quickly see which is which. So you can see this is my squared, this is my cube, this is my 2 power, this is my e, and this is my 3 power. So that's a really nice way of doing things. The exercise I have for you is to create the sin, cos, and tan, or sine, cos, and tan functions on one graph like this. You will have to manipulate the x and the y axes. You'll have to use a linspace to get a test linspace for you to be running those functions on, and then you'll have to create a legend and label them all. And I'd also encourage you to play around with colouring them in. There's a load of different optional arguments here, like colour equals black will give us this line as a black line. There's loads of different things we can do here. I've kind of just touched the surface of what we can do, but for now, sine, cosine, and tangent functions on one graph, add a title, add axes labels. Those are other things that you can look into, and then try using the subplots command to create all three graphs on one plot, but each one has its own subplot. So that's the exercise for you to do. Next time we're going to be looking at how to import data into Python using pandas, so hopefully I'll see you then.